Welcome to a new series of mine, applications of differentiation. We'll be starting it off with critical points. I figure that's a good place to start, and I'll be showing you how to get critical points from a function. Now, don't ignore this. I buggered that up and I had to restart the video. But first, in critical points, you got to find the critical number, and then use the critical number to find a critical point. So when you find the critical points, it can either be when the derivative is set to 0 or the derivative is undefined. And then when you grab the critical numbers from whatever process you did, and you put that's the critical number. Whatever answer you get for x is the critical number. And then you sub that into the original function, not the derivative, sub it back into the original function, and then you get the critical point. That's what you're looking for. Now this is derivative equals 0, and derivative is, that's does not exist, or undefined. And basically over here, when you got the critical point, when you sub it back into the function, you find out if it's defined, so if it exists within the domain of the function. So if the answer comes out not defined, then it's not a critical point. It's a critical number, but it's not a critical point. But if it does come out defined, it is a critical point. Okay, so think about it this way. If the whole does not exist, defined, undefined, is a bit confusing because it confused me at first. So when something, let's just say, does exist, we'll use DE for does exist and does not exist. So when something does exist, let's say it's a fraction, and that's 0 over 2. Think of it as 0 over 2. And then when it doesn't exist, you got 2 over 0. So usually when it's just by itself, if you've got a liner, one line, it'll be, you'd use just set it to 0. But if it's a fraction, you got to find the derivative. You got to set the derivative of the top to 0, and then you work that out, and then you go back and you set the bottom to 0, and then you work it out. And that's essentially setting the bottom to 0 when it's when it doesn't exist or it's undefined. So think of it this way: you can always have 0 of something, but you can't have 2 of nothing. So it's undefined. You can. It's defined if it's 0. If it's 0 on the top over a number, because it's something, but it's not defined when it's 2 of nothing, because you can't take something from nothing, but you can take nothing from something, if that makes sense. Okay, hopefully that was a good enough intro. I'll just start with an example now. So example 1, we'll say function equals 2x squared plus 2x plus 1. Okay, so first step is to derive it. And that'll be 4x plus 2. And now we don't have a fraction, so we don't have to worry about setting the derivative to being undefined or not existing, which would make it 0, but we only have the top part. We only have a single line. Think of it, a single line. So we would then just set the derivative to 0, and that would mean 0 equals 4x plus 2. Then you rearrange it to find x. So you bring the 2 over, negative 2 equals 4x, negative 2 divided by 4 equals x, and so therefore x equals negative 1 over 2, because 2 over 4 is the same as a half. Okay? And you've got your critical number now. So now we need to find the critical point. And that's when we sub it back into the function. So we take this critical number and we sub it back in. So that would be negative a half. And that would equal 2 negative a half squared plus 2 multiplied by negative a half plus 1. which is the original function, just with negative a half subbed in. And that all comes to 1/2, which is good. So basically, if you type it into your calculator and you come out with a number, it's defined, in my experience. If you type it in and it comes up mathematical error and carries on, then it's not defined. So it doesn't exist, which therefore, in this case, there's only one critical number, and there's only one critical point, which was a half. And so therefore, you could say, therefore, x equals negative a half is a critical point. Okay. Now I'm going to do one more example to finish up this introduction. I will do more videos on this in different examples and for practice and just different examples and together. But there'll just be one example per video. This I'll just do this one just because it's a introduction video. So here we have example 2. Function equals 3x squared over 1 minus x squared. Okay, so we're going to need the product rule for this because we have a function over a function and we derive it. So the derivative will be u dash v minus u v dash over v squared. Okay, so that'll be the derivative of u, that'll be, you bring the 2 down, 6x multiplied by v, which is 1 minus x squared, minus u, which is 3x squared, multiplied by the derivative of v. The derivative of v is just negative 2x, and that's it. Okay, and that'll be all over 1 minus x squared, and then it's v squared. This is just v, so we're going to square the whole thing. Okay, so we're going to now expand it out, and what we're going to get is 6x subtract 6x to the power of 3, subtract this will be plus, because negative multiplied by negative, 6x to the power of 3. So these will cancel out, negative, because 6x to the power of 3 minus 6x to the power of 3 is 0. And we're just left with 6x, and that is all over 1 minus x to the power of 2, all squared. Okay. So, now, here's when you get to defined and, or, this is when we get to it, the derivative equals 0 and the derivative is undefined. Okay, so let's start with, basically, when you set the derivative, in this case, when you this topic, when you set the derivative equal to 0, you basically have 0 equals 6x. You don't focus on the bottom half. Later, when you set the derivative does not exist or is undefined, then you set 0 and you have the bottom. And the bottom in this case is 1 minus x squared all squared. Okay? So when you set the derivative to 0, you focus on the top half, and when you set the derivative to undefined, you set the bottom half to 0, which makes sense because I explained earlier, when the bottom of a fraction is 0, it's undefined. So setting the derivative to undefined or not existing means you set it to 0. This bit was the tricky bit for me to wrap my head around. That bit was easy, but this bit was the tricky bit. Okay, so now let's just do this bit. So if we divide both sides by x, by 6, well, 0 divided by 6 is 0, and these two cancel out, and you just get x. So therefore, our first critical number is x equals 0, which is as shown. Okay. And for this one's a bit different. Okay, so we have it's squared. So instead of expanding it out, we're not going to expand it out. What we're going to do is we're going to square root both sides. So the square root of 0 and the square root of 1 minus x squared and squared. So therefore, that will cancel the square root, and it will cancel this. The squared will cancel the square root, and the square root of 0 is 0. So now we're left with just 1 minus x squared. Okay? So what I'm going to do now is I'm going to split it up, and it's going to look like this. Okay? So I'm going to make it look like 0 equals 1 minus x, 1 plus x. Okay? Now, that there equals this. If I were to expand this 1, and then an x, and then negative 1x, and then negative x squared, then it would look like this. I'm just unexpanding it. So instead of expanding it, I'm factoring it. You could think of it as. But anyway, so this is what I'm doing, because this will get one value and it'll be a pain to explain. This is much easier to explain. So here, now we're focusing on just setting either one of these to 0. So 0 equals 1 minus x, and over this side 0 equals 1 plus x. Therefore, x equals 1, and on this side, x equals negative 1. Okay, so now we have 2 points. This would have given you the same answer if you did it properly, but I just like doing it this way. So essentially, x equals plus or minus 1. Okay, so we have three values, three critical numbers, which is x equals 0, x equals negative 1, and x equals 1. Now we're going to sub that back into the original function. The original function was 3x squared over 1 minus x squared. Okay, so we're going to sub in 0. It's going to give us 0 on top, 1 minus 0. Therefore, it'll be 0 on 1, which is correct, because you can take nothing from something, which makes it defined. Because there's still a whole thing there. You just there's no fraction of it. There's nothing been taken. You could think of it as. So there is something there. It's just there's no portion of it that has been taken or written. So that's defined. Okay. If you were to input negative 1, that would be that'd be 3 negative 1 squared over 1 minus negative 1 squared. That's the problem, because yeah, you would on top you would have that would be equal to 1, because negative 1 squared is 1, and you just have 3, but that'd be over 1 take negative 1 squared is 1, so it'd be 1 take 1, which would equal 3 on 0, which is a problem that does not exist. Okay, because here you're taking, think of it as you're taking nothing from something, but here you're taking something from nothing. You can't take something from nothing, but you can take nothing from something. As confusing as that may sound, that's the way I got my head around it. So here we have just 1, so it's 3 1 squared all over 1 take 1 squared, which is going to be the same thing. It's going to be 3 over 1 take 1, which is 3 over 0, which is wrong, well, not wrong, it's the correct answer, but it's just doesn't exist because it's not defined within the domain. Okay, now I hope this video helped on getting you started on critical points. Not to get critical points confused with critical numbers. They are a part of critical points are a part. Have to do with critical numbers, but critical numbers are not the points themselves. Anyway, thanks for watching. I hope you learnt something and have a good day.